In this video, we will make a rub surface by writing a script combining both Kangaroo and Hoopsnake. The surface responds to an external factor, in this case a sphere, in a real-time fashion. In other words, wherever the sphere travels, it will leave an impression on the surface. We will start by creating a surface, then set one surface, reparameterize it, and making that into a mesh. And set a slider to control the number of subdivisions on the mesh. Then we will decompose that mesh to extract the vertices and making them into points. Simplify it and graph it. We'll open up the Kangaroo button and then exploding the surface to extract the vertices as anchor points for Kangaroo. So, making the mesh the geometry for Kangaroo. We'll apply U-force on each of the points extracted from the mesh. And make that only along the z-axis. Then we will hide everything first. And set one point and use that point to create a mesh sphere, and use a slider to control the size of the sphere by its radius. Then we will use the mesh inclusion button and then importing all the points from the mesh surface to find out which points are within the sphere. And then we can use that data. By using the dispatch button, we can separate the data into two sets of separate data. One set inside the sphere and the other set outside the sphere. And then we need to turn these points into a scalar value using vector length. So that it will give us a number value instead of a point. And then using evaluation, and then giving it an expression, x over x multiplied by y. Y is the number that we can control using a slider. We can then apply a constant number onto each of the points from that data tree. And then doing the same thing to the B list. We're changing the expression to x minus x so that we will get 0 for all the points that's outside the sphere. And by using the clean tree button, we can eliminate all the null and invalid entities from the data tree. And finally, we'll merge the two sets of data back together. And have a complete set of data that gives us only a constant application for the u-force or 0. Connecting that set of data back to the z direction of the u-force. Then open up the Kangaroo setting and give it a slider to control the sub-iterations. That controls the number of calculations per step. Connecting the Boolean toggle back onto Kangaroo. Then decomposing the mesh coming out of Kangaroo. And making it back into a NURB service for preview purposes. Give it an expression +1. We hide all the objects first, and then flatten the force objects in Kangaroo, and add the timer, setting the intervals to 20 milliseconds, and then we'll test. So as you can see, the mesh surface continues to deform even though it has already left the surface of the sphere. That is because it keeps calculating whether the points on the mesh is still within the sphere, the mesh sphere, using the original mesh rather than the distorted one. So we need to use Hoopsnake to bring back the geometry output into the geometry input continuously to achieve our purpose of having a real-time responsive rub surface. We'll disable the timer and open up Hoopsnake. Connecting the mesh surface to the starting value of Hoopsnake and the feedback value to the decomposed mesh, and joining the geometry output to the data of Hoopsnake. And also joining the feedback to the NURB surface. We'll now test the script by turning both Hoopsnake and Kangaroo on. So as you can see, the script re-evaluates the current condition of the mesh surface affected by the sphere. Rather than with Kangaroo alone, which keeps re-evaluating the original unaffected mesh, with Hoopsnake the mesh stops deforming once the mesh points leave the surface of the sphere. We can also vary the size of the sphere to increase the size of the imprints on the mesh. And also vary the strength of the U force and also its direction. If we try to move the sphere on top of the already deformed mesh, it will start to affect the current condition of the mesh instead of its original orientation.